So it gives me great pleasure to hand over to Ioanna, who's partly funded by CIMA, and she's going to talk to us about what we do with the tissue.
Thank you. So, hello everybody. My name is Ioanna Pangou, and I'm a research technician. I'm funded by CIMA. I'm also the person designated for the Newcastle Bone and Joint Biobank. So, I'm going to be talking about the usage of samples, human samples in research. So a little bit about me. I'm actually from Cyprus. I came here to study and I graduated from Newcastle University in 2014. I'm a registered scientist and I'm also a member of the Royal Society of Biology, and I'm a part of Professor Laughlin's osteoarthritis and genetics group. So the disease we're studying, arthritis, is affecting more than 7 million people in the UK. And there are more than 200 types of arthritis and rheumatic diseases. Not only adults are affected by this, because 1 in 1,000 children are born or have arthritis, and is more affecting females than males. I've taken those numbers from the State of Musculoskeletal Health 2018 from Arthritis Research UK. So in this picture, I'm showing how many hip replacements and knee replacements are performed. Those are the numbers from 2016, and those surgeries are due to osteoarthritis. So it's actually a significant number of surgeries. So in the following slides, I'm going to have samples from humans, from patients. So I'm sorry if you are squeamish. We focused on a lot of different projects in Newcastle University, so we have different biobanks. I'll be talking about the Newcastle Bone and Joint Biobank because that's the one I'm responsible for. And as part of the biobank, we have different type of samples. So we get hip samples, we get knee samples, we get also thumb samples, we call them trapeziums. From the hip sample, we can get the neck of femur, and also if you get the cavity, you can get bone marrow from inside the cavity. From a knee sample, you can get quite a lot of things. We can get the fat pad, the synovial fluid, we can get it from the synovial cavity. We also get meniscus, and we get the cartilage. I'm doing a lot of work with cartilage. So I just want you to know that we just don't get samples and start using them. We need to have ethics and we need to have a license in order to be able to use them and store them. So for the different projects that we have, we go through research ethics committees and we get approved. Our projects gets approved in order to be able to use the human samples. And to be able to store the samples, we need to have a human tissue authority license, and the university is covered by that, so everything is regulated. I'm going to talk you through the life of a sample, from collection to recording, processing, storing, and finally the disposal of samples. None of this will be possible without the amazing team we have at the Freeman Hospital and at the RVI. So those are the research nurses team that we're working with, and they provide us with consents, they inform the patients, they provide them with information leaflets, they let them know about the research we do at the university. So we work very closely with the NHS. So in the morning, I usually get an email from the nurses. They let me know if we have eligible patients, and if the patient has agreed to consent, we collect the sample from the hospitals. So that's like an overview again of the samples that we're getting. This is a hip sample. I have a picture of a knee and a picture of a thumb. We also get some blood samples as well. So in that picture, I have the healthy joint, the healthy knee, and I also have an OA knee. This is a sample I got. So you can see in this picture that the cartilage is intact. You can see that the color, it looks healthy, and is not damaged. And in this picture, you can see the cartilage is destroyed. I mean, here you can see the bone, so you can understand that the patient must have been in pain. That's why they had the total knee replacement, and we got this sample after the surgery because the patient consented to use this sample in research. When I come back to the university, I record everything. So we have information like if it's a female or a male patient, we write down the age of the patient, the type of the surgery, if it was a total hip or a total knee replacement or a trapeziectomy. We also have information like the body mass index, and we have information about the disease. We don't have any information that identify the patient, so everything is anonymized. When I'm processing a sample, there are two routes to that. So I'm assessing first the condition of the sample to make sure that it's not too destroyed, to see that it's actually possible to be used. And I'm either grinding the tissue samples and I'm using them to extract the DNA and the RNA from them, or I'm digesting the tissue with different enzymes and I get cells. The cells that we get from cartilage, we call them chondrocytes. I'm going to talk about both of the procedures with you. So I'll talk first about the grinding tissue and using DNA and RNA in research. So these metallic pots, we use them to put the cartilage in it. We have two, and we use this machine, we call it the grinder. So this shakes quite vigorously, and then the cartilage from inside these pots, it just becomes like a powder, and then we're able to extract it more easily. And then it looks like that after processing it. So the first phase is quite colorless, so it's the top one, that's the RNA. The bottom one is white, is the DNA, and the last one is the proteins, is the pink phase. Once I get the DNA and the RNA extracted, I pass this on to the researchers and they do further testing with them. But this is my stage. I just give the materials. I give DNA and RNA, and I also give the cells. So for cells, we use different enzymes, and then we culture them. This is just an example of, again, hip. Those are hip samples. It's not eye bulbs. So those are two hip samples, and this one is a knee. I've taken this picture from Dr. Juliet. I'm getting the cartilage and I'm processing it for chondrocytes. So when I get a sample, I just make sure I make most of it. So when you digest the tissue, it looks something like that. And we use these bottles, we call them flasks, to culture the cells. And the chondrocytes looks like that. I've taken this picture from Raoul. So you can see the cells here. Sometimes we use most of the tissues that we get at this moment, but sometimes it's necessary to store them in order to be able to use them in the future, but that doesn't take like that long. So again, I'm recording everything. I'm writing the number, what type of a sample it was, when it was frozen down, and those are my initials. So that's why it's really important to have the biobank to be able to make most of it, to store the tissues that cannot be used right away. So that's some pictures of the freezers that we have. So the last route of the sample is disposal. So that's either if a sample hasn't been used because it was too damaged, or when you get most of the sample and you use it, then you just dispose the rest. And we do this accordingly to the rules. We just dispose the samples within incineration, and we use like bags like this one, autoclavable bags. So that's the life of a sample, and that's me. Thank you very much for your attention.